Hey everybody. So today we're going to be exploring square root. Unfortunately, we don't have the pegboard material with us in our homes, so I thought I'd demonstrate a way to do the work on paper. Okay, so what I've done is I've started a reference table to help you in some of your responses. Now, square root is closely associated with the exponent power of a number, and when you work with the square value, the square exponential power of a number, you're taking that number by itself two times. So let's think of area and the idea of length times width. Focusing with the square, the area of a square is going to be the base, 5 for example, multiplied by the side. It being a square, that will also be by 5. So 5 squared, 5 times 5 equals 25. The area of a square of 5 would be 25. We're going to reverse that idea when we look at square root. Okay, square value shows where the form is coming from, and square root shows the root in the beginning of that value. So if you had a square of 25, the square root would be 5, because that would be that line, that baseline at the bottom of 5 square, if I'm clear. So what I'd like you to do is finish these in your own cahier, write out the responses, the tableau. You'll be needing it for reference. And then I'd like you to include the symbol for square root that we would have seen before with all the responses to your multiplications. And then also the result. The square root of 25 is 5. For the others, I'd like you to write the response for the square root. Let me know if you come across any patterns. Now, that's the first activity. Second activity is I've included 4 fractions that are not a common square value. 42, for example, is going to have a remainder. And so let's explore some ways that we can find the remaining value of square root if they don't themselves have a proper square value. So I'm going to choose our first question as the example to do. That's the square root of 42. Okay, and this is going to be a little bit like division, what we're looking at right now. You want to ask yourselves, what square value from my reference table can I fit into 42? Okay, now the square value of 6 is 36, and the square value of 7 is 49. 49 being a greater number than 42, so we can't use it. But 36 being a lower number than 42, that's what we're going to do to begin solving the square root with the remainder. Our first response, like I said with the division, you write down what value you were able to share equally in it. And so what we have for our first response is 6, the square value of 6 being 36. Okay, now we are not finished yet, because the square value of 6 is 36. So we need to find the decimal value that can be multiplied by itself in order to come to 42, or as close as we can to 42. Okay, so what I did here to help understand what was going on is I looked at the difference. I looked at the difference between the square value of 7, 49, and what we're looking at, 42. The difference is 7. Then I looked at the difference between the value that can satisfy the square of 42, and I found that that difference was 6. And so this is my exploration. Okay, 6 is lower, which means that the square value of 36 is closer to 42 than the square value of 49. All right, and I'm actually going to, just on a lark, use that as my first decimal value. So you can see from my multiplications down below, as I'm just experimenting, I want to see if 6/10 added to 6 whole will multiply to find a value close to 42. And so this is a bit of experimentation. I've taken 6 and 6/10 and I've given it a square value, 6 and 6/10 multiplied. And then what I find as a result is 43 and 56/100. That number is too large. Okay, it's 1 unit, 1.5 units greater than 42. So I continued my experimentation. If 6/10 was too high, what about 5/10? And so again, with estimation, some level of experimentation is expected. So now taking the square value of 6 and 1/2, or 6 and 5/10, we have as a result 42 and 25/100. So we're much closer now. With 43, we're outside the value of 42. but with 42 and 25 hundredths, we're still within the value. And so without being precise to the thousandths or the 10,000ths, I'm really just looking for a response to the hundredths or the tenths. And so for me, myself, 6 and 5 is an appropriate square root value, for 42. And we've tested it by doing the multiplication, 6 and 1/2 times 6 and 1/2, and that gets us to a value that rests within the quantity of 42, though we are 25 hundredths over. Now, there were 4 questions that I had asked, that I'm asking to be done in your cahier. We've worked the first one together. And so finish your tableau, see what you can find for those square values that can satisfy the next 3 questions, and then play around with your multiplications to see how many tenths, how many hundredths, and if you're really eager, how many thousandths can be multiplied to that response in order to get the most precise square root value for these numbers. Okay, we're gonna have office hours on Tuesday morning, and I'm happy to answer any questions that come across until then. You're also able to share your questions through the feed by typing them out, and I'll get back to you as soon as possible. Take care and good luck, everyone.